Let's take a quick look at some principles around nuclear chemistry. So far in this course, we've been looking at reactions that are involving the electrons in an atom, so things that are outside of the nucleus. Nuclear chemistry involves reactions in the nucleus. So we're going to be looking at very different particles, very different parts of the atom. I do want to make sure that you make that distinction. Nuclear chemistry is only dealing with particles in the nucleus. We'll also be looking a little bit at radioactive decay. So it's when we have a nuclei or nucleus, so the unstable nuclei are going to form more stable nuclei. So remember, the nucleus is the center of an atom. So you've got your protons and your neutrons. So protons are positive and our neutrons are neutral. So neutral protons, positive 1, neutrons 0 charge. So these are neutral. We'll talk about what these numbers mean in just a moment. So they're in the center of the atom, so in the nucleus. And remember, our electrons are negative particles and they're zipping around on the outside of our atom. Okay. When our nucleus goes through some sort of change to form a more stable nucleus, it gives off various particles through a process of radioactive decay. And so it's going to give off different types of radiation depending on the type of decay it's undergoing. We'll look at those in just a moment. But first we need to look at and review a little bit on isotopes. So you've looked at isotopes previously in the course. So for example, I have helium-4 here. It can be written as helium-4 or helium with a 4 on the top and a 2 on the bottom. The top number is the total number of protons and neutrons. So in this case, it's 4. So that means, and the bottom number, Z, is our number of protons. So the protons, we can always find that from the periodic table. So for helium, this bottom number, if we look on the periodic table, helium is element number 2, so it's always going to have a 2 there. That's the very definition of what helium is. This 4 tells us how many more neutrons that we have. So in this case, I have 4 total protons and neutrons. So if I want to know the number of neutrons, I can take my A number, subtract the number of protons, and that gives me the number of neutrons. In this case, the number of protons and the number of neutrons are equal, but that's not always going to be the case. So we'll take a look at some examples. So let's practice some. So how many protons and neutrons are in the following compounds, or following elements? Do note that I did not include the Z number on these. You need to find that Z number from the periodic table. So it's just you take a moment to pause the video and find the number of protons. And then we'll take a moment to find the number of neutrons. So if we look on our periodic table, uranium here, if we look on the periodic table, is element number 92. So its number here is going to be 92. Hafnium, if we look on our periodic table, is element number 72. This is element 72. Carbon is element number 6. Iodine is element 53. Chromium, element 24. So that tells you the number of protons. So our protons for each of these, we have 92, 72, 6, 53, 24. Right? If we want to find our number of neutrons, we're going to simply take that top number, so 238, Minus 92 is going to give us our neutrons. 180, 72, 14, minus 6. So make sure and check that you've calculated the number of protons and the number of neutrons for each of these isotopes. So notice that these masses do not correspond with the masses in your periodic table on some of these isotopes. Remember, these are the total mass of a particular atom of this type of element. So a particular isotope of this atom or this element. We're looking at single atoms here. The masses in your periodic table are the average of all of the atoms of that type that exist. So do be careful about that distinction.